In this video, we're going to talk about net ionic equations, and we're going to take a look at some double replacement reactions and use our solubility rules to figure out what's going to form a precipitate and what's not. So I put three reactions up here on the board, and for each reaction I included the word equation, the molecular equation, the complete ionic equation, and the net ionic equation. I did each in a different color. And what this is designed to do is paint a full picture of what's actually happening within a solution as you perform a double replacement reaction. So for sodium phosphate and calcium nitrate, since it's a double replacement reaction, at the end you're going to get sodium nitrate and calcium phosphate. And again, whenever you're writing the formulas for an ionic compound, you're using the charges to dictate what the formula is. So given those word equations, sodium is a +1 ion, phosphate is a -3 ion. So when they combine, you're going to have 3 sodiums for every phosphate. Nitrate's -1, calcium's +2, and that's why this is our formula for calcium nitrate. Now, once they switch, notice I don't carry over this subscript 2 saying there's 2 nitrates, because the product, we're going to make the formulas based entirely off the charges. So sodium nitrate, sodium's +1, nitrate's -1, it's a 1-to-1 ratio. Calcium's +2, phosphate's -3, so you're going to have 2 phosphates for every 3 calcium. So again, formulas are based off the charges. Then we went back and balanced the chemical equations using coefficients, and now we have the same amount of each element on both sides. So out of our 2 products, we have sodium, which is +1, nitrate, which is -1. If you look at your solubility rules, you see that sodium and nitrate are always soluble, so they're never going to form a precipitate. When we look at calcium and phosphate, however, you're going to see that phosphates are usually insoluble, meaning they're going to form a solid when they react with something, unless it's sodium or other alkali metals or ammonium. So using your solubility rules, you'll predict this is the solid compound. Now, the complete ionic equation basically says what's present in the solution before and after the reaction. So before the reaction, the ions are all floating around. And now some are going to combine to form a product, and that's what we call the net ionic equation. But writing the complete ionic equation, you have the sodium ions, the phosphate ions, the calcium ions, the nitrate ions, all floating around. Now what's going to happen is your calcium and the phosphate ions are going to collide with each other and form a solid that will get cloudy and then eventually precipitate out of the solution. But the sodium ions and the nitrate ions are still floating around in solution. They don't really do anything. We call them spectator ions. So our net ionic is what actually happens in the solution. It excludes the stuff that's just floating around. So we really just had calcium ions and phosphate ions combined to form calcium phosphate, which is a pure solid. And that's what the precipitate is. Now, using our solubility rules is what we're going to need to do to predict which product is going to be the solid or not. And sometimes you can mix solutions together where you get no solid product. Now I've gone through and done 2 more reactions for you to follow here. I don't think I need to go through every single step, but take a look at those at your own time and make sure you can make sense of them. Sometimes you can have solutions come together where they don't actually form a precipitate. For example, sodium nitrate and potassium acetate. The double replacement reaction products would be sodium acetate and potassium nitrate. Both of those would be aqueous. So essentially you have just all the ions floating around and no solid forms. For this case, you would just write NR for no reaction and you're done. And the reality is, aqueous systems, like your tap water, have many, many ions dissolved. If they weren't dissolved, they would have precipitated out and they wouldn't be what makes it to your faucet. So it's not necessarily like an aqueous system can only have 2 ions. It can have a multitude of them that are just dissolved without doing any reaction.